Hey guys, hi. This is Abhishek, Master Teacher of Physics at Vedantu. कैसे चले मेरे बच्चों की जिंदगी? एकदम बढ़िया बच्चों. All of you guys doing really good. How are you guys doing in today's morning? All well, all well. कितने लोग जल्दी उठ गए थे? मैं तो काफी लेट उठा यार. Today is Abhishek Sir's birthday. अच्छा, आयुषी से मुझे पता ही नहीं था कि मेरा बर्थडे आज. नहीं बेटा आज नहीं है मेरा बर्थडे. हाय अभिजीत, हाय खुशी, हाय एवरीवन. तो पीपल टुडे वी आर गोइंग टू डू समथिंग वेरी वेरी इंटरेस्टिंग. और वो क्या इंटरेस्टिंग होने वाला है आपके सामने, आपको पता है ऑलरेडी, आपने टाइटल पढ़ लिया होगा. इट्स कॉल्ड एज इक्विलिब्रियम एंड पॉम पॉम. So POM is nothing but principle of moments, people. That's what you're going to understand today. One of the major topics from which you get numericals in your board examinations as well in your school examinations. ठीक है, तो आज का फ्लो बहुत अमेजिंग है. We'll understand first what is equilibrium in a very fun way. And after that, once you understand equilibrium, you wouldn't have to be taught what is principle of moments. You will understand by yourself. तो आज बहुत मजा आने वाला है बच्चों. I'm going to keep the session very short, and in this short amount of time, we'll play a lot of games as well. Yes, people, we're going to play a lot of online games. उसका लिंक भी मैं आपको दे दूंगा. और उस गेम्स के थ्रू हम समझेंगे कि प्रिंसिपल ऑफ मोमेंट क्या होता है, इक्विलिब्रियम क्या होती है, एक चीज को इक्विलिब्रियम में लाने के लिए हम क्या कर सकते हैं, एंड व्हाट आर दी बेसिक अंडरस्टैंडिंग अबाउट ऑल द प्रिंसिपल ऑफ मोमेंट्स कॉन्सेप्ट. लेकिन आई एम प्रीटी श्योर कि ऑल ऑफ यू गाइस नो, आज के सेशन में हम ज्यादा न्यूमेरिकल्स में नहीं घुसेंगे. आज हम कॉन्सेप्ट्स कर रहे हैं, न्यूमेरिकल्स भी करेंगे, लेकिन द मेजर अमाउंट ऑफ न्यूमेरिकल्स गोना कम फ्रॉम ऑल द टॉपिक्स टॉर्क, couple, equilibrium and principal of moments in the next session. I'm going to dedicate an entire session for numericals for all these topics, क्योंकि बहुत सारे numericals आ जाते हैं. ठीक है, तो वहां पे करेंगे. लेकिन आज आगे बढ़ने से पहले बच्चों एक बार जोरदार बल्ले बल्ले हो जाए. Everyone can hear me clearly? क्या बात है. Thank you so much people. Superb Sachin. Hi everyone. Thank you so much. Thank you so much Adhav. Thank you so much. So people get ready. It's going to be amazing. We are going to enjoy a lot and a lot of topics today. आज बहुत सारे games भी खेलेंगे. तो make sure that you're there till the end of the session. Make sure that you're there till the end of the session because a lot of games comes on your way. ठीक है? So I will start in the next 15-20 seconds. I just want to give a quick hi to everyone. Hi Krishna. Hi Balle people. Welcome to this session. I'm seeing that now in our ICSE sessions also a lot of you guys are coming and I'm superbly proud of that. And today when the session started, it already had more than 100 likes. Thank you so much. We'll just like to remind all of you guys कि भाई साहब पिछले सेशन में हमने रिकॉर्ड बनाया था that within the session, before the session got ended, it crossed 500 likes. That was the record which we all made. Let's break that record today. Shall we? Shall we? How much do you guys think we'll be breaking the record? How much do you guys think today will make the likes too? What do you guys think? Hi everyone. Hi Kashish. Hi Kanish. Anil. Mridhanvas. Navya. Hi Sanju. Hi everyone. Hi Satish. Hi everyone. Thank you so much. Yes, Panther, Blaze. Yes, people. Thank you so much, Satish, Alok, Murali. Yes, fantastic people. Thank you so much. You guys are super sweet. I know you guys are. है ना? 6,000. अरे 700. अच्छा चलो 700 का टारगेट रखते हैं. बहुत ज्यादा रियलिस्टिक लग रहा है. खुशी श्रीवास्तव जी ने कहा हमें कि सर आज 700 का रखते हैं टारगेट. अरे बिल्कुल 1000 भी इतने कोई बात नहीं. चलो ठीक है, 700 का टारगेट रखते हैं हम कि विल बी क्रॉस 700 लाइक्स और नॉट. ठीक है, चलो बहुत बढ़िया पीपल. इट्स सो स्वीट ऑफ ऑल ऑफ यू गाइस. थैंक यू सो मच. विदाउट स्पेंडिंग एनी मोर टाइम, लेट्स गो अहेड एंड स्टार्ट. ठीक है, so as always people, I'll be starting the session today with a very interesting information which I always give out to you guys to secure your own educational career. And what is that people? And that's this. That's Vedantu scholarship admission test, one of the most sorted out scholarship tests out there because the registration is absolutely free. You can write down this examination, attempt this as the examination sitting at your home on a Sunday. Just spend 2 to 3 hours and make your educational career absolutely secure. And let's be less burden on our parents when it comes to finances of your education. Thousands of students have already written this particular examination and crores of scholarship has been already given out. Every student who attempts this examination gets a short scholarship, and the better you score, the more scholarship you get. Right? So people, here is the link for that, vdnt.in/ytvsat. तो इस लिंक पे उसको नोट डाउन कर लो या तो चले जाना लिंक पे और सीधा जाके एनरोल कर देना. हर संडे को एग्जामिनेशन होता है. एंड यू कैन सी दैट पीपल एट द एंड ऑफ दिस, एट द बॉटम ऑफ द स्क्रीन आल्सो कैन फाइंड आउट दैट लिंक एवरी सिंगल टाइम. Cool. Okay. Now, starting the session now with a very beautiful quote, and I can completely relate to this quote today. And that quote says, "The only difference between a good day and a bad day is your attitude." So people, what do you guys think is your attitude today? Is it a good attitude or a bad attitude? Are you guys ready to make it a good day by just changing your attitude towards the day today? Right? Agree with me? है ना? चलो, give a quick high five. And that's the spirit. With that, let's start the session. So I'm pretty sure that all of you guys are aware that we have completed the topic of torque and couple. That was the first session. If in case you haven't watched that yet, you should go ahead and watch it up. But anyways, today I'll take a quick flashback of all the topics you studied because principle of moments and equilibrium depends on torque and couple or moment. ठीक है, तो आज हम उसके बारे में फ्लैशबैक करने के बाद स्टार्ट करेंगे आज का सेशन. ठीक है, today we are focusing more on equilibrium principle of moments. Tomorrow's session will be focused on numericals on torque and POM. Dedicated session for only numericals, so make sure you're attending that. So let's go forward and do a quick flashback of all the things we studied from the previous session related to torque and moments, because a lot of topic of that is going to come in today's session also. तो जिन्होंने भी नहीं देखा है वो इस flashback को ध्यान से देखना, लेकिन बाद में आके वीडियो जरूर देखना. ठीक है, चलो. The first question which came up in the flashback is this: to form a couple, the forces should be equal in magnitude, parallel and opposite, separated by distance, all of the above. What do you guys think is the correct answer for this question, people? Let's go forward. मचाया चेस जी, क्या बात है? जब बताओ जल्दी बच्चों, क्या लगता है उसको आंसर? I'm looking forward for the on the chat right now. Thank you so much, Mansi, means a lot. A, okay. C, D, okay. Few of you guys go for D, few of you guys go for C. The first person who gave me the correct answer was again Gangadhar. Gangadhar, you are there in ICSE 10th session also. भाई तू कौन सा ग्रेड का है? So people, Gangadhar Prasad. He comes in my CBSE 9th session also, CBSE 10th session also, ICSE 10th session also, and he gives the correct answer every time. Gangadhar, you change your answer, bro, now. What is this, buddy? What is this? Okay. Take it. Okay, people. Okay, fantastic. Achha, ठीक है. So I could see a few of you guys go for D, few of you guys go for A. Few B also, few C also. So that means it's absolutely necessary for us to revise कि what is a couple. है ना बच्चों? What is a couple? So couple को रिमाइंड करने के लिए मैं बहुत ही सिंपल से एग्जांपल लूंगा अभी यहाँ पे, इस पे ध्यान से देखना बच्चों. So what's a couple? A couple is, as it states, something which is in pair. Now what is in pair right now here? It's the force. The forces are in pair now. तो अगर मुझे इस बॉटल को खोलना है, as you can see, when I'm trying to open this bottle, turn this bottle, I'm applying the force two places, at one here and the other here. है ना? That's how I'm trying to open this bottle. Now, the force I'm applying here is directed this way, and the force I'm applying here is directed this way. But the magnitude of these forces is equal. The magnitude of these forces are equal. क्योंकि मेरा एक उंगली दूसरे उंगली से ज्यादा force नहीं दे सकता ना. It's going to be the same force, isn't it? So I'm going to open it like that. So what happens here is, obviously they are equal in magnitude, proven. They are equal in magnitude, done, sorted, right? And number two, they are parallel and opposite. That's also true. And obviously you would have noticed that the force, one force is here, the other force is here. Correct. One force is here, the other force is here. So they are separated by distance as well. So that means it's all of the above, people. All of the above. Please understand that. A couple is nothing but a pair of forces which you use to open or, create rotational motion in any of the object which is pivoted at a point. Got the point? So it's pretty simple. Every single time, anytime you forget about what is a couple, remember the example, opening a bottle cap. Examination में याद नहीं आ रहा, अपने पानी के बॉटल को देख लेना. पानी का बॉटल अलाउड एग्जामिनेशन, उसको देख लेना, याद आ जाएगा, अच्छा ये कपल था, सर ने बताया था. ठीक है, remember that. Cool. Now, so that's a couple. So a couple should have all these, as in categories, that the forces should be equal in magnitude, they should be parallel and opposite, and should be separated by a distance. Cool. Okay. सबको समझ में आ गया? बहुत easy. Okay. Now question number 2 on your screens, people. Question number 2. It's a very interesting numerical out there for you to revise the formula of couple or formula of torque. Two forces each of magnitude acts vertically upwards and downwards respectively at the two ends A and B of a uniform rod of length 4 meter, which is pivoted at its midpoint. Determine the magnitude of the resultant moment of force about the point O. क्या लगता है? Students, like, where do I live? In India, bro. The teaching makes everywhere. Thank you so much, Shreya. Thank you so much. Shreya, you are also here. अरे क्या बात है? Everyone who doesn't have much clarity about torque, I would request you guys to go ahead and watch the previous session. ठीक है? There's no, हाँ, obviously Sarita, this is an ICSE session, ना? It's not a CBSE session. तो CBSE में कहाँ होगा बेटा ये? Okay, क्या लगता है उसका आंसर? A लग रहा है? अच्छा, okay. Let me just see how many of you guys giving the correct answer here. I could see that a lot of you guys started with A and B. Shanvi is also here. क्या बात है? Okay, A. Okay, D is also there. बल्ले बल्ले. C, D. Oh, I can see majority of you guys going with option D and C. Majority going with D and C. ठीक है. पूछा गया हमें to find out the moment of force, है ना? Determine the magnitude of the resultant moment. Oh, determine the magnitude of the resultant moment of force about the point O. तो resultant moment of force कैसे निकालते हैं? बहुत ही सिंपल सा तरीका है बच्चों, जैसे यहाँ पे है ना? Resultant moment निकालने का एक सिंपल सा फॉर्मूला है. That is basically asking us to find out the moment of the couple, है ना? Moment of couple, ये निकालना है. उसका फॉर्मूला क्या है, पिछले सेशन मैंने पढ़ा हुआ है, अगर आपको याद नहीं तो पढ़ लो अभी। मोमेंट ऑफ कपल का एक बहुत ही सिंपल सा फॉर्मूला, एंड दैट इज टेक ईदर ऑफ द फोर्सेस, टेक ईदर ऑफ द फोर्स, सो magnitude of either of the forces, magnitude of either of the force into the distance between the forces, into the perpendicular distance between the forces is the formula of couple। अगर याद नहीं है तो याद कर लो अभी, है ना, पिछला सेशन देख लेना। तो इसका क्या आंसर आ जाएगा, मैग्नीट्यूड क्या है भाई 10, 10 into 4 कितना हो गया 40, तो 40 न्यूटन मीटर becomes the moment of force और moment of the couple, ठीक है। सो इट शुड बी 40 न्यूटन पर मीटर क्लॉकवाइज। कांग्रेचुलेशंस पीपल। नाउ क्लॉकवाइज मेंशन करना क्यों जरूरी है, क्योंकि ये 10 का न्यूटन, ये 10 न्यूटन फोर्स ऊपर की तरफ डायरेक्टेड तो ऐसे घुमाएगा, है ना, इसको ऐसे घुमाएगा, और ये 10 न्यूटन फोर्स नीचे की तरफ डायरेक्टेड तो ये ऐसे घुमाएगा, है ना। तो अगर मेरे पास ये ऑब्जेक्ट है और 10 न्यूटन फोर्स ऊपर की तरफ है और ये 10 न्यूटन नीचे की तरफ है, तो कैसे घुमा रहा है वो उसको क्लॉकवाइज घुमा रहा है। So 40 Newton meter clockwise becomes the correct answer, not 40 Newton meter anti-clockwise. So people who are getting confused, people who are confused with clockwise and anti-clockwise, अभी के अभी इस कंफ्यूजन को दूर भगाओ, क्योंकि मेरे अभी भी दोस्त हैं बहुत सारे कॉलेज में जो लेफ्ट को राइट बोलते हैं और राइट को लेफ्ट बोलते हैं, ठीक है। तो ऐसे गलतियां मत करो, समझ रहा है, ऐसे गलतियां मत करना। आई कैन लिटरली अज्यूम कि पीपल हु से लेफ्ट राइट एंड राइट लेफ्ट, how superbly they would be confused with clockwise and anti-clockwise. I know that. I have real life examples with me. नमूने हैं मेरे पास, वो नमूने आप मत जाना, ठीक है बच्चों। Remember that with you. Good. Okay. So moving ahead right now, people, to the final question for the flashback. The next most important thing which you need to remember for today's session, that is this question. Listen to this very, very carefully. If the forces acting on the couple are in the same direction, that is, they are not in the opposite direction, then what? For example, if I just have to explain to the bottle again, imagine करो मैं यहाँ पे ऐसे खोल रहा था ना, अगर मैं इसको ऐसे खोलूं, if I try to open this like this, or if I try to open like this, will something gonna happen? Is something gonna happen, people? Come on, think about this. Oh, is it Sanju? Oh my God, bro, that's too intense. Which one? See? Is it C? Yeah, obviously, right? The couple will not exist. The couple will not be possible, right? The first question itself stated for a couple to exist, the force should be separated by a distance. The force should be parallel and opposite in direction. Then only the couple can exist. Otherwise, it cannot. Correct? Congratulations, people. Now you guys have basic idea about couple, and I'm proud of that. Congratulations, people. Very well done. So all these topics were taught in the concept of torque and couple in the previous session. नहीं देखा तो देख लेना. And also, I gave out a very simple numerical for you guys to solve in the homework, and a lot of you guys gave the correct answer to this question in the homework, and I'll be taking those names who gave the answer. Just give me a second. So the question was, a nut is opened by a wrench of length 10 centimeter. Length was given as 10 centimeter, converted to meter is 0.1 meter. If the least force required is 5 Newton, find the moment of force needed to turn the nut. So the moment of force, that is torque, is equal to force into distance. Force is given as 5 and distance is given as 0.1. When you multiply it, you will get the answer as 0.5 Newton meter. Correct answer. And the first person to give me the answer in the previous session was Sakshi Singh. Congratulations, Sakshi. Kya baat hai. So Sakshi, if you're there, congratulations, beta. बहुत बढ़िया, बहुत बढ़िया, बहुत बढ़िया. Second person was Preksha with a very good example. Then Shamim gave me the answer. Amrita gave me the answer. So everyone who gave me the answer here, congratulations. ठीक है. There were a few more. I think it was Bhavna who came the 6th. Namita gave 7th. Shamim again gave homework. Okay. And Sanya Rai gave me the 8th question. So everyone who will be watching this session, everyone whose name are here, congratulations. Do let me know in the comments how did you feel. Today also, people, I'll give you a homework and I will see how many of you guys give the correct answer. ठीक है. चलो अब आगे बढ़ते हैं. अब हम आते हैं बात हमारे कॉन्सेप्ट जिसको हम कहते हैं इक्विलिब्रियम. लेट्स अंडरस्टैंड व्हाट इक्विलिब्रियम इज. So yesterday when I was making this content, I thought about something. I created a challenge to myself. मैंने सोचा मैं बच्चों से पूछूंगा कि बच्चों, when I say about equilibrium, what word comes in your mind? अगर वो मेजॉरिटी बच्चे का जो वर्ड है वो मैंने गेस मार दिया तो मैं अच्छा टीचर हूं, वरना मैं नहीं हूं. ठीक है. So what do you guys think? What word comes in your mind when I say equilibrium? What word? Let's just say. Let's see what is the majority of the people telling me the answer. What word comes? Stability. Okay. Equal. State of balance. Equal. Stable. Thank you so much, Reena. Yes, stability, equal, balance, stable. Array, stable. Okay, equal. इक्वल। ओ ये तो गड़बड़ हो गया ये तो मैं तो गलत गेस मार दिया, मैंने गलत गेस मार लिया। But yeah, stable also is coming up. Equal is also coming up. Oh, but I could see that majority of it is going with equal and stable. Like what word comes in your mind the moment you say equilibrium? The word equal comes in your mind. हट बेशर वो मैंने सोचा कि आप लोग stable बोलोगे, मैंने तो stable लिख दिया. You guys are telling me equal. Shameless. नहीं पढ़ा रहा मैं. But yes, people, equal, stable are those words which comes in every one of us mind the moment we hear about the word equilibrium. Right. Any object which tries to achieve stability, any object which is stable in whatever kind of motion they are in. If they are at rest, they should be at rest. That would be stability. If someone is moving, the person should be moving, and that's stability for them. So that is equilibrium. है ना बच्चों? Balance, equal, stability. Very good path. Congratulations, people. That's the word stable. So now we'll go ahead and understand कि भाई ये stability equilibrium कैसे achieve कर सकते हैं. How can we achieve this equilibrium? How can we achieve this stability? Let's go ahead and find that out. I'm pretty sure you are very well aware about the first type of equilibrium or first type of stability. I know you are. Let's consider a box lying on a table, people. ठीक है? That's the table, and on this table there is a box lying, as you can see. My question to everyone is, people, I'm applying two forces on this box. One towards this direction, which is in 10 newtons, and the other in this direction, which is in 20 newtons. My question to everyone is, in which direction does the box move? Towards the left or towards the right side? Left or right? Come on, give me a quick answer. Which direction does the object move? First law of Newton, obviously, Joshi ji. 10 newtons towards west. Let's put that in left or right. Cat, let's put that in left or right because मेरा भी थोड़ा west और east का लोचा है. The left or right, people? It's towards the left, right? It's towards the left. You guys think so? Yeah, absolutely. You guys are absolutely correct. So when I try to find out the resultant force, है ना? When I try to find out the, भाई साहब पेन का मैं अंधा तो नहीं हो गया? हाँ चलो पेन निकालते. हाँ. So when I try to find out the resultant force, how do I find it? Forces in this direction minus the forces in the other direction, then I get the resultant force. है ना? That's how we find. So resultant force RF would be equal to 10 newtons minus 20 newtons. So I'll get the answer as minus 10 newtons. So minus means this direction is negative. That's what I've taken as 20 newtons in this direction. So I've taken that direction as negative. So that means your object moves in the direction of the unbalanced force, which is towards the left. Sorted. We are very cool about it. So can we say that this object is stable? It's stable? The answer is no. Because the object was at rest. Now it is no longer at rest. So how can it be stable? If an object has to be stable or if an object has to be in equilibrium, the object should maintain its state of rest or state of motion. Here the object is not doing that. So yeah, sorry bro, you are not in equilibrium right now. But let's try to make it equilibrium. What about now, people? What about now? Is the box on the table now in equilibrium or now in stable position? What do you guys think, people? What do you guys think? 10 Newton, 20 Newton, 10 Newton and 20 Newton from this direction and 20 Newton from this direction. Is the object moving towards the left or towards the right? Thank you so much, Joshi ji from Gujarat. Left. Now also it's moving left. Left or right? Zero. No, right? It's not in equilibrium, right? Absolutely, it is not in equilibrium. Why? Because the resultant force, if I try to find it out, the forces in this direction is 10 plus 20. It's 30 Newton, and the force in this direction is minus 20 Newton. So I see that the answer comes out to be positive 10 Newton, which is directed in this way. So still there is a resultant force on this box. That means due to this resultant force, the box will move towards this direction. So again, it has not achieved stability. It is not equilibrium. Correct? Congratulations, people. Very well done. Now, final question. What about now? अब क्या बोलोगे आप सर? अब क्या बोलोगे? Is the object going to move or not? Yes or no? Has this object achieved stability now? Balle people. Very good. Yeah. Zero. Yes, Gangadhar ji. Yes, it is zero now. It is equal. It is stable now. Fantastico. Yes. If I try to find out the resultant force here, हमें क्या मिलेगा बच्चों? इसको हम क्या बोलते हैं? यहां पे रिजल्टेंट फोर्स अगर हम निकाले तो कितना आएगा? 10 न्यूटन minus 10 Newton. Answer आ गया 0. That means there is no resultant force acting on this object at the end of the system, and that literally means the object is stable. The object is not going to move. The object was at rest, and after putting a lot of forces on the object is still at rest. तो अब जितना भी फोर्स डालो कोई फर्क नहीं पड़ता भी इसको. So that means this object is now stable. It is in equilibrium, और इसे हम कहते हैं बच्चों equilibrium, bro. when the resultant force on any system is equal to under. I love this part. I love this part so much. When the resultant force is equal to under, that's when we say the object is in equilibrium, people. Got that point? Got that, everyone? Yeah. Yeah. Thank you so much. Thank you so much. I believe that you guys love that under wala part. I personally love that a lot. Yesterday when I was making this content, I realized the under dalna bahut zaruri hai. It all boils down to one small under. It all boils to some one small egg somewhere. Yeah. Got it? Got it? Yeah. Okay. Okay. So this was about a normal general thing which you have studied. ठीक है, तो ये equilibrium में है. लेकिन बात ये है कि this box was in a translational motion, है ना? इसको मैंने ऐसे धक्का मारा तो वहां गया, ऐसे धक्का मारा तो वहां गया, ऐसे दोनों तरफ से मारा धक्का नहीं गया, सही ना? रोटेशनल मोशन में क्या करेंगे? ये तो ट्रांसलेशन मोशन था. What will you do in rotational motion? Let's talk about that also ना. बुरा लगेगा बेचारे को. तो बच्चों मैं कंक्लूड कर लेता हूं जो अभी हमने पढ़ा, ठीक है? And that is, so when a number of forces acting on a body produces no change in its state of rest or motion, the body is said to be in state of equilibrium. यहाँ पे हमने देखा कि resultant force 0 आया तो there is no change in state of rest or in motion. Let's talk about another scenario. Now I'm going to take up a seesaw. These two objects are at equal distances from the center of the seesaw. ठीक है, मैंने उठा लिया, चलो समीर को उठा लिया मैं. Is it so? Is it Samir? कोई बात नहीं. Samir, come up. Samir, I'm going to take you as a volunteer here, and I'm also going to take it Sushma. So Sushma and Samir, you guys have just joined. No, so this is Sushma sitting here on one side of the seesaw, smiling. And that is Samir sitting on the other side of the seesaw, and he's also smiling. Oh, nice. Both of them have curly hairs. I'm going to make you handsome now. Okay, that's Sushma. That's Sashi. Sorry, Samir. Right. So both of them are sitting on the seesaw at equal distances. I have not mentioned who is heavy. I have not mentioned the weight of Sushma or Samir yet. I have just mentioned that both of them are sitting at equal distances from the seesaw. दोनों चलो मान लिया 2 मीटर और 2 मीटर के डिस्टेंस में. ठीक है, ये हमने मान लिया. Cool. Okay. Now my question to everyone is, in this scenario of a seesaw, the seesaw can rotate. The seesaw can rotate. So to achieve or to check for equilibrium in this case, we will consider only resultant force or resultant moment और both A and B. What are we going to consider about here? Resultant force के बारे में सोचेंगे, resultant moment के बारे में. ये momentum नहीं है, ये सिर्फ moment है, ठीक है? ये गलती हो गई, ये moment है सिर्फ. तो resultant force के बारे में सोचेंगे, resultant moment के बारे में सोचेंगे हम कि both A and B सोचेंगे. किसके बारे में सोचेंगे? जल्दी बताओ बच्चों. C लग रहा है ना? Swordfish. Exactly. Thank you so much, Usha Yadav, for putting up egg on the chat. Thank you. Yes, Parth, definitely. Let's see, people. We have to think about both of them. क्योंकि moment is also a rotational force. A tangential force which causes rotation, right? That's also a sort of force. So when we say to achieve equilibrium, all these sorts of forces on the system should be zero. Resultant force should be zero. We have to think about that tangential force also, भाई. सिर्फ एक force के बारे में सोच क्या करेंगे, है ना? चलो देखते हैं कि force कैसे होता है. तो हमने सीसो को दोबारा उठा लिया. अब अभी भी सुषमा और समीर बैठे हुए हैं. ठीक है? Now also Sushma and Samir, they are sitting on the seesaw. Just imagine. Let's imagine that Sushma is putting a force downward. Her weight is 20 newtons. Sushma's weight is 20 newtons and Samir's weight is 30 newtons. Okay. Both of them are sitting at equal distances, 2 meter, 2 meter. People, are they in equilibrium? Are they in equilibrium? Yes or no? What do you guys think? Yes or no? Hi Sushma. Sushma, I've taken you as a volunteer also. राजेश जी, मेंटी? ना बेटा, अभी तो कॉन्सेप्ट पढ़ना है. मेंटी तो हम चैप्टर के एंड में करेंगे. Yeah? They are? No, right? They are not. No, Nandana? Yes, Rajesh? They are not, right? Yes, Technical? Poonam? No, they are not. Nishant, right? Gangadhar also? Sanju? Yeah, they are not in equilibrium. Absolutely. Why? If I try to find out the moment or the torque from this direction, okay, what will I find out? So torque would be, due to this particular force, I can see it would be 20 into 2. So the answer would come out to be how much? 40 Newton meter. And this moment will rotate this moment will rotate this seesaw in what direction? Anti-clockwise. It will rotate it in anti-clockwise. So I'm going to take it as positive 40 Newton meter because anti-clockwise moments or anti-clockwise torque is taken as positive value. Now similarly, if I talk about this torque here, it would be 30 newtons into 2 meter again. So this would be 60 Newton meter. And due to this torque of 60 Newton meter, the seesaw is going to rotate anti-clockwise. ये नीचे की तरफ आएगा ना यहाँ पे. So it will rotate anti-clockwise. So this I'm going to take it as negative. Correct. This torque is equal to negative 60 Newton per meter. So it's obviously they are not in equilibrium. If I try to find out the resultant moment, how much would be 60 minus 20? I'll get to the answer as 40 Newton meter. Sorry, 60 minus 40. I'll get this 20 Newton meter is the resultant moment. So due to this moment, what's going to happen? The object is going to rotate anti-clockwise. See, so is there a bend ho jayega? Correct. We all know. Acha, what about now? What about now, people? Is now the state of equilibrium achieved in this particular case of seesaw? Is now it is achieved? What do you guys think? Yeah? No? No? Yeah? Hey Angridev, what's up? Hand wash Mohit, kya baat hai? 20 meter clockwise? Very good Nandana, very good. Agreed Toshiji, in some sense, not in every sense. Only one class for ICSE Usha Yadavji? We are trying to do as much as we can, beta. Yesterday there were 4 classes Usha, you didn't check it out. What do you guys think about this answer, people? Thank you so much, Raya, means a lot. Here it is achieved, here the equilibrium is achieved. Oh, I see there is a small internet issue, it's okay people, it's okay, it will be fine, don't worry about it. Ho jayega, chill nahi. What do you guys think? Yes, it is achieved, no? Equilibrium is achieved here, isn't it? Fantastic. Oh, the internet is fine now. Great people, great. Congratulations, you got it right, correct? You got it right. So how do you get this here? Pretty simple, bhai sahab. Yahan pe it would be 20 into 2. The answer comes out to be 40 Newton per meter. And that should be positive. And here it would be 20 into 2. The answer would come out to be 40 Newton per meter. And this would be negative. So as you can see, the resultant moment would be 40 plus 40 minus 40. The resultant moment would be 0. So what does this mean, people? What does this mean? If in the case of to achieve equilibrium, when we are talking about moments, if the resultant moment is also equal to under, then if the resultant moment is also equal to under, then we can say that the object is in equilibrium. है ना? Abhishek ji, कैसे बोल रहे हो? It is achieved ना सही है ना बच्चों? So it all boils down to under only. So equilibrium is equal to under. Equilibrium itself is equal to under, people. Got the point? Okay. So we just understood two basic criteria of achieving equilibrium, and those two conditions are here. सबसे पहले हमने पढ़ लिया कि number 1, the resultant of all the forces acting on a body should be equal to 0, which we proved with the example of the box and the table. Correct. Number 2, we just understood with the example of the seesaw that the algebraic sum of all moments of all the forces acting on a body about the point of rotation should be also 0. Correct, people? Yes, Aditya, ये पूरा था अंडे का फंडा हमने क्लियर कर दिया. So these were the conditions of equilibrium, and this question comes for 2 marks in your ICSE board examinations. What are the conditions to achieve equilibrium? And these are the conditions. If this question could also come for 3 marks, where you have to give a very sweet example also along with these statements. You can take the example of the seesaw, or you can take the example of the box, or whatever examples you want to take. Cool, people? So everyone, we have understood the conditions of equilibrium. Give me a quick high five. Thank you so much, people. You guys are amazing. है ना? मजा आया? सबको मजा आया बेटा? Right? So now we'll be going on forward with again a very interesting topic called as types of equilibrium. A very interesting topic, very interesting topic. इसको भी हम बहुत मजे तरीके से समझेंगे, एकदम मस्त तरीके से समझेंगे. ठीक है? Okay. Everyone enjoyed the session till now? कितने हो गए likes? आज का हमारा टारगेट कितना? 700 है हमारा टारगेट. खुशी ने बोला था कि सर आज 700 रखेंगे. तो मैं देख पा रहा हूँ कि हमारे यहाँ पे likes हो गए हैं 288. Closing to 500, not yet close to 700. Come on, people. Everyone who has been enjoying the session till now, hit that like button right now. Subscribe to the channel. All of you guys who haven't yet. Yes, we have crossed 300 likes right now. Keep hitting the like button, people, as much as you like the session. ठीक है? So, thank you so much. Thank you so much. बहुत बड़े people. बल्ले बल्ले. चलो, ठीक है. Thank you so much. Thank you so much, Mokshit. Yes, yes, निशांत. बिल्कुल निशांत, बिल्कुल. Thank you so much, Nasi. Thank you so much, beta. Thank you so much. Now, part 700, na? Chalo, ठीक है. So, people, let's go forward for the next topic of types of equilibrium. Everyone now, shh, concentrate. ठीक है. बहुत easy है वैसे, बहुत ज़्यादा easy है. पहला टाइप ऑफ इक्विलिब्रियम होता है जिसको हम कहते हैं स्टैटिक इक्विलिब्रियम. अब मैंने दोबारा अपने आप को चैलेंज दिया कि मुझे पता है कि स्टैटिक वर्ड जो सुन के बच्चे सिर्फ एक वर्ड बताएंगे और वो मैं पक्का गेस करूंगा. मैंने कल ही सोच लिया. सो गाइस, व्हाट वर्ड कम्स इन योर माइंड द मोमेंट यू हियर स्टैटिक? इस बार डोंट डू दैट टू मी. इक्विलिब्रियम को स्टेबल बोला था मैंने, आप लोगों ने इक्वल बोल दिया. स्टैटिक के लिए क्या बोलोगे? कम ऑन. What do you guys think, people? What do you think about static? It is, thank you so much. Stationary, now, Nandana, thank you so much. Position, rest, stationary. Thank you so much. Thank you so much. Yes, I love that part. Now Sarthak and Nishan, they are like stable for this. Throw this pen on your face. Equilibrium means stable, you already said. Now this is stationary, right? Static means stationary. So people, it's pretty simple. It's pretty simple. What is static equilibrium? If an object is at rest, and a lot of forces are applied on it, or a lot of moments are applied on it, and even after all this, if the object continues to be in state of rest, static equilibrium. ये तो कहीं सुना लग रहा है सर, ये तो हमने स्टार्टिंग में पढ़ लिया. हाँ, this is static equilibrium also, bro. When the resultant force is equal to under, ये बॉक्स का एग्जांपल बहुत ही परफेक्ट है स्टैटिक इक्विलिब्रियम के लिए. हमने यहाँ पे दो फोर्सेस को अप्लाई किया बॉक्स के ऊपर, लेकिन बॉक्स रेस्ट पे ही है. It hasn't moved. It hasn't moved at all. The state of rest is maintained. The state of stationary position is maintained, and this is what we call it as static equilibrium. There will be one more example, and that is this. That too, bro. That too. Imagine now, Sushma and Samir are, pulling the rope towards each other. And what's happening? The rope isn't moving. Because the rope is like, bro, I want to achieve static equilibrium. And that's what it is achieved. Isn't it? So yes, static equilibrium is achieved. The rope is not moving. The rope was at rest. Now still it is at rest. Simple. Super simple. That's static equilibrium for you. I'll define it once again for all of you guys. Static equilibrium is achieved when the object which was at rest continues to be in a state of rest after a lot of forces or moments are applied. Continues to be. It's similar to Newton's first law of motion. If an object was at rest, it will continue to be in rest. Inertia, first law of motion, whatever you say. Next one is dynamic equilibrium. Ab mujhe batao, next challenge. What do you think about dynamic word? What word comes in your mind from dynamic? I'll give you a very simple example. Dynamic is exactly opposite to static. Static is stationary, so what is dynamic, people? Static is stationary, so what is dynamic? It is Balle, balle, people, balle, balle. What is the duration of this class? Smart learning with Anvesha. The duration of this class might go on forever. Motion? Fantastic. Is it? Motion, yes. Dynamic means motion. Very good, people. It's exactly opposite to static. That is stationary. Dynamic means motion. So, I'll just say the same statement what I said about static equilibrium. I'll just change the word rest or stationary to motion. Kaise? Dynamic equilibrium is achieved by any object if in case it is in motion and after applying all the forces and resultant moments, it still will be in motion only. उस पर कोई फर्क नहीं पड़ेगा, ना ही ऑब्जेक्ट रुकेगा ना कुछ होगा, उसको वो कंटिन्यू करता जाएगा. सर अभी इसका एग्जांपल क्या है? इसका एक बहुत ही ब्यूटीफुल एग्जांपल बच्चों, जैसे हमारा एयरक्राफ्ट होता है. Correct. An aircraft flying at a constant height is a very good example of this particular dynamic equilibrium. How? Aircraft एक पर्टिकुलर हाइट पे कॉन्स्टेंटली कैसे फ्लाई कर सकता है? वो तभी फ्लाई कर पाएगा, वो तभी उड़ पाएगा. द ट्रैजेक्टरी विल बी द सेम ओनली व्हेन द वेट ऑफ दिस एयरक्राफ्ट इज इक्वेटेड बाय द लिफ्ट generated by the aircraft. Now you might be wondering, sir, what is lift? Lift is the force generated by the aircraft to go upward. There should be an upward force to go upward. No? So it's created by the aircraft's wings to go upward. That is called as a lift. So when the lift becomes equal to weight, that's when the aircraft is leveled. But the aircraft is still in motion. The aircraft is still in motion when the lift and the weight are equating each other. है ना? This is a very classic example of dynamic equilibrium. I hope you guys got the point. Thank you so much. Thank you so much, Aditya. Thank you so much. I believe all of you guys understood this and all of you guys loved this part. Thank you so much, people. It was an amazing part. So, and there's one more very amazing example is the planet's motion around our sun. ठीक है, वहां पे अगर आप देखोगे, I'm pretty sure you all are aware कि this all looks like circular orbit, but I'm pretty sure you know that the planets do not revolve in circular orbits, they revolve in elliptical orbits. But doesn't matter circular or elliptical. आपको पता होगा, if I talk about this particular planet here, that small blue colored planet, which is also called as Earth, that planet never goes out of the orbit. है ना? That planet never goes out of the orbit. जैसा मेरा प्लेन कांस्टेंट हाइट पे ट्रैवल करता है, वैसे मेरा अर्थ एक कांस्टेंट डिस्टेंस पे ट्रैवल करता है सन के अराउंड. एलिप्स हो तो एलिप्स है, लेकिन वो ऑर्बिट कभी नहीं छोड़ता है. क्यों? बिकॉज इट इज ऑलवेज काउंटर्ड बाय द सेंट्रीफ्यूगल फोर्स एंड द सेंट्रीपिटल फोर्स. राइट, द अर्थ is balanced by the centrifugal force of its motion and centripetal force of the sun. है कि नहीं बच्चों? This is something very interesting which we all studied, isn't it? Correct? ये आपने पढ़ा होगा already. Correct? I'll tell you guys again if in case you are not aware of this. The earth is pulled, every planet is pulled towards the sun due to gravitational force, also called as the centripetal force, also called as the, you will be studying this year, I'm pretty sure. It's also called as the centripetal force. The last topic of this chapter will go in detail about this. So the earth is pulled by the sun called as gravitational force. And since the earth is pulled towards the center, that kind of force is called as centripetal force. Due to this force, the earth should have come and hit the sun, no? Because the sun is pulling the earth. And so it is pulling all the other planets also. So every planet, due to this gravitational force, should have come and collided with the sun. Why doesn't that happen? The moon does not collide with the earth. Why doesn't that happen? Isn't it? That doesn't happen because every object, every planet in the solar system is moving. And whenever every object moves in a circular motion, it has an outward force also associated to it. You don't believe me? You just have to do one thing. You have to take something rotational and you start rotating it. And if you leave this now, what you're rotating, where does it go? It goes outside. It doesn't come inside. It never comes and hits towards your hand. It doesn't come. It always and always goes outward. It always goes outward. Why? I am pulling this through my hand, right? I'm pulling this object towards my hand. So it should come and hit my hand, right? Why is it not hitting? Because every object in circular motion also experiences an outward force, and we call that force as centrifugal force. We call that force as centrifugal force. So, and that is the reason why every object, remains in that orbit, because centripetal force becomes equal to centrifugal force. We'll be talking about this particular topic in very much detail in the last part of this chapter, people, so do not worry about it. Okay, I hope you guys understood this part. Thank you so much, Sanskari ji. Thank you so much. ठीक है people. So, जैसे लिफ्ट और वेट कांस्टेंट होने की वजह से एयरप्लेन इक्वल हाइट पर रहता है, वैसे ही सेंट्रिपिटल फोर्स और सेंट्रिफ्यूगल फोर्स कांस्टेंट होने की वजह से आपका अर्थ ऑर्बिट पर रहता है. ठीक है? So that were the examples of people, the concept of centripetal and centrifugal force. ठीक है? चलो. अब बच्चों, we'll go ahead and understand the concept of principle of moments. Thank you so much for staying back with me till now, क्योंकि अभी हम खेलेंगे एक बहुत ही इंटरेस्टिंग सा गेम. और इसमें आप लोग मुझे चैट पे धनाधन आंसर देते रहना, और जो आप आंसर मुझे दोगे उस हिसाब से, मैं अपनी तरफ से कुछ नहीं करूंगा, मैं अपनी तरफ से कुछ भी नहीं करूंगा. जो आंसर आप दोगे उस आंसर के हिसाब से मैं गेम में वैल्यूज इनपुट करूंगा. अगर वो सही आया तो सही आया, वरना नहीं आया. ठीक है बच्चों, देखते हैं सबसे पहले आंसर कौन देता है. रेडी पीपल? गिव मी अ क्विक थम्स अप, गिव मी अ क्विक बल्ले बल्ले ऑन द चैट राइट नाउ. कम ऑन पीपल, लेट्स गो. या रेडी? फैंटास्टिक. ओके, चलो. So give me a moment. I'll set up the game for all of you right now. Okay, set up the game. Every people who will be watching this as a video, get ready. Okay. So let's just see. Yeah. Okay. You will be able to see the game right now. You can obviously see the the link to the website where you can play this game as well. It's not a website created by Vedantu. It's created by Fed Colorado. You can definitely go ahead and play this game whenever you guys are free. ठीक है बच्चों? तो सभी बच्चे देख पा रहे हैं इसको? Yeah. Cool. बल्ले बल्ले. Sorted? ठीक है. So now I'm gonna go into the level 1 of this game. You have to answer me the questions and you're good to go. You have to answer me the questions and good to go. Cool. So I'm entering to level 1. There's a seesaw. As you can see, there's a seesaw which has been marked with 1, 2, 3 and 4. There is a mass of 10 kg kept at the distance of 5 meters. This 1, 2, 3, 4 are 5 meters. ठीक है. So where should I keep this 10 kg to balance this? Where should I keep this 10 kg to balance this, what we have learned now? Where should I keep it? What do you guys think? कहाँ पे? You should keep it 5 itself, at 5 itself, है ना? At 5 itself, correct? Congratulations. You said like me. I'm not going to say anything. 5, 4. 5, 4. Okay. So few of you are telling me, sir, keep it at 2. अच्छा ठीक है, let's keep it at 2. I'm keeping the 10 kg at 2 and I'm going to check it. No movement at all. Okay, let's try again. Okay, let's shift this to 4. What every one of you guys are telling. Nope, still no movement at all, people. Okay, let's try again. Oh, it moved a bit. That means if I just move this to one more point, what will happen if I try to put that up exactly at the same position as the other one is, then yes, it might get balanced. Correct, people? It might get balanced. When I restarted it, the values of this changed, but the concept remained the same, isn't it? What did we just prove? We did the same thing what we did with the case of the seesaw, right? We did the same thing what we did with the seesaw. There were Sushma and Sameer. Sushma was putting 20 Newton and Sameer was also putting 20 Newtons, and that's the reason why seesaw was balanced. Similarly, here also 15 kg is kept at 6 and this 15 kg is also kept at 6. So if I find out the torque, come on, quickly find out the torque people. अगर मैं इसका torque find करूँ जल्दी से क्या आंसर आ जाएगा मेरे को? चलो torque निकाल देखते हैं, ठीक है? अगर मैं 15 kg का torque find करने की कोशिश करूँ, कितना आएगा? 15, okay, 15 into 6 कितना आता है मेरा आंसर? 6. Actually cannot do 15 into 6 because 15 is in kgs. मेरे को न्यूटन में कन्वर्ट करना पड़ेगा, but that would be 150 into 6. तो आंसर बोलो सेम है तो मैं सिर्फ सीधा आगे बढ़ रहा हूँ, ठीक है? But if in case you want me to do it, I'll convert into newtons. But I hope that's okay, right? So 6 by the 30, 3 carries into 3. 90 newtons यहाँ पे हो गया, 90 newtons वहां पे आ गया. So what did you just do is you made it all right. You made absolutely it all right. Your anti-clockwise movement became equal to clockwise movement. Correct? Correct, people? You got the point? Got the point? Well done. Well done, people. Well done. And what you did just now, people, is called as principle of moments. That's all it is. That's all it is. What you just did right now is called as principle of moments. We'll continue the game right now, do not worry, but I just wanted to mention to all of you guys. So according to principle of moments, see, sum of the anti-clockwise movement is equal to sum of clockwise movement. और जब ये दोनों equal हो जाएंगे, जब total anti-clockwise movement become equal to total clockwise movement, that's when the equilibrium is achieved. And that is what is principle of moments, and you guys told me already. Isn't it? Congratulations, people. Very well done. You guys did a fantastic job. Let's continue this game and let's try to see whether we still understand all the principal moments or not. Shall we? Okay, let's go forward and let's try to understand it once again. ठीक है? अब मैं second game की तरफ जा रहा हूँ. इसको ध्यान से देखना बच्चों. Look into this very carefully. ठीक है? So I'm going to go forward for the next game. Come on, you guys tell me what will happen. Think about this. You have this seesaw in front of you. One 10 kg object is kept at 8 meters from the center of the seesaw. One 5 kg object is kept at 8 meters from the center of the seesaw. You guys have to tell me which of the three things is going to happen here. What will happen? Will the seesaw fall towards left hand side? Will the seesaw fall towards the remain balanced? Or will the seesaw fall towards the right hand side? क्या लगता है आपको? A, B or C? 10 kg will go down. Shanvi tells me sir 10 kg will go down. है ना? ठीक है? सही में? Towards the left? Towards the left? Thank you so much, people. Got it right? Yes, you guys got it right. Sir, it should be, come on. Let's try to find out the answer to this with the help of calculation. 10 kg is at 8 meters. So the torque would be somewhere about 80 kg meter. I'm saying it wrong because it should be 80 Newton meter. तो उसको मैं न्यूटन में कन्वर्ट करूंगा तो I just multiplied with 10 ना. Acceleration due to gravity. Weight is equal to mg. तो acceleration due to gravity 10 होता है. तो 10 into 10 100. 100 into 8 is 800 Newton meter. और यहाँ पे कितना हो जाएगा? 5 into 10 is 50. 50 into 8 is 400 Newton meter. तो इस साइड में 800 Newton meter लेकिन यहाँ पे 500 Newton meter है. So this is definitely not in equilibrium. Should be the correct answer. Let me check. Ooh, plus 2 points, people. Plus 2 points. Congratulations. You guys are playing really well. You guys are playing absolutely well. Okay, let's go on to the next one, people. Come on. What do you guys think about this? You have a 10 kg object which is kept at 6. You have a 10 kg object which is kept at 6. You have a 20 kg object. You have to keep it in such a way that it is balanced. So where do you want me to keep this 20 kg? Remember, you just have two chances. You cannot go more than 2 chances. Thank you so much, Pankaj. Where do you guys think? Where should I keep it? 1, 2, 3, 4, 5, 6, 7, 8. Okay, Sanju tells me sure you should keep it at 3. Nishan tells me 3. Cat tells me 3 meters. 3 meters. You guys tell me 3 meters. Okay, let's calculate this. Majority is telling me 3 meters. Fantastic. Let's just find out. So 10 kg multiplied into 10, weight becomes 100 newtons. 100 newtons into 6, the torque generated is 600 Newton meter. मेरे पास 20 kgs है. 20 into 10 is 200 newtons. 200 into 3 is essentially 600 Newton meter, which will be equal. Okay, so you guys seem to be correct. तो रख के देखते चलो. And we keep it at 3. Let's check it up. Voila! It is balanced, people. Congratulations! Well done, people. Well done. Next game. Plus 2 points again to you. Next game. What is the mass? This is a very interesting. This is the hard part here. This is the hard part. So you have to find out what is the mass of this bucket. Okay, what is the mass of this bucket? How can you find it out? You can only find it out when the object is in equilibrium. When the object is in equilibrium. तो हम क्या करेंगे? इस 20 kg उठा के 1 पे रख के देखते हैं कि बैलेंस होता है कि नहीं. ठीक है, इस 20 kg को उठा के हम 1 पे रख के देखते हैं कि बैलेंस होता है कि नहीं. और ये तो बैलेंस हो गया भाई. देखो 20 kg को we kept it on the one part and it got balanced. So guess and tell me what should be the weight of the bucket? What should be the weight of the bucket? 20 kg, Nishan? 20 Nishan, isn't it? You right? 20 only, Manpreet? Yes, 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 yes. Fantastic. अरे बिल्कुल जोशी जी आपसे क्लियर हो रहा है 20 ना बहुत बढ़िया yes it should be 20 so let's put this as 20 and see whether we get it right or not ठीक है चलो 20 पे रख देते हैं हम चेक करके देखते हैं oh we are good at this game we are absolutely good at this game okay we have just two more okay next game here right now on your screen this is the last second one what will happen अगर मैं चेक करूंगा तो what will happen A B or C 20 kgs at 4 and 10 kgs at also at 4. So what is going to happen? It's going to shift towards the left, it's going to shift towards the right, or it's going to remain balanced. It's going to remain balanced. Left or right or balanced? What do you guys think? Yeah? Yeah? Thank you so much, Simran. See? It's going to fall down towards this. It's going to fall down towards the C. What do you guys think about? पागल हो गए हो C कैसे जाएगा? Okay, look into this. यहाँ पे weight ज़्यादा है और ये 4 पे है तो if I find out the torque here 20 into 10 is 200 newtons that's the weight it's at 4 meters distance so 200 into 4 gives me 800 newton meter as the torque which is in the anti-clockwise direction here 10 kg is 100 newton weight which is multiplied by 4 I get 400 newton meters which is half of this so that means obviously the object is going to go down towards the left and we got that right. Thank you so much, people. Congratulations. Great amount of response. Great amount. कितने likes हो गए यार? It's this must game के लिए कितने likes हो गए? अरे we are at 400 likes right now. Come on, people. The target is 700. We need to reach that 700. Let's go. Let's go. Let's go. Hit that thumbs up button right away. We are moving on to the last stage of challenge of this particular game. And your question is on your screen. Come on. I want correct answers. You have to find out the weight of that particular flower. Come on, you have to find out the weight of that particular flower. You guys tell me where should I keep this 10 kg? You guys tell me. Where should I keep this 10 kg? You guys tell me. A smart? Yes, almost that smart. But Newton's first law of motion was basically related to the translation motion, not rotation. Okay, you guys telling me to keep it at 2. At point 2, you guys telling me. Okay. Okay, I'm putting this at 2. Let's see what happens. Oh, it didn't balance. Sorry bro, sorry guys, it didn't balance at 2. So if it is not balancing at 2, that means you cannot find out the weight yet. You have to balance it up, then only you can find out the weight, है ना? Equilibrium में आना पड़ेगा ताकि formula apply कर सकूँ. 3 पे रख के देखें. Let's try it at 3. अच्छा ठीक है, let's try it at 3 now. Okay, see. You guys have to understand this. Please understand this. If when I'm keeping it at 2, the seesaw is going downward, right? Because the torque here is already more. The torque on the right hand side is already more. So if I move it to 3, the torque will even more increase, na? Don't you think so? The torque will even more increase. Why? Because the distance is increasing. And as the distance increases, the torque increases even more. So it will be a wrong choice to go away from the center now. Yes, let's try to keep it at 1. If I try to keep it at 1, the torque should reduce now because the distance is reducing. Torque is equal to force into distance, people. Remember that. So I'm moving this object towards the 1. Oh, it balanced. It balanced, people. It balanced. So now tell me, if the object is at 10 kg, and the torque is now balanced, what is the weight of that flower flower pot? What is the weight? It is 10 kg. Yeah, agreed. Chalo. It's not 10 kgs. Obviously, it should be 5 kg weight. Very good, Shanvi. Exactly, because this particular object is in the second position, है ना? Torque कितना generate हुआ देखते हैं. Torque कितना हुआ? 10 into 1. एक बार calculate कर देखते हैं, ठीक है? 10 into 1 करके देखते हैं. 10 into 1. Sorry, 10 into 10 into 1 क्योंकि 10 into 10 वेट करना है ना तो टॉर्क आ जाएगा आपका 100 न्यूटन मीटर ठीक है दैट इज गिविंग यू द क्लॉकवाइज मूवमेंट दिस क्लॉकवाइज मूवमेंट शुड बी इक्वल टू द एंटी क्लॉकवाइज मूवमेंट ACM व्हाट इज द एंटी क्लॉकवाइज मूवमेंट मास तो मुझे पता नहीं फ्लावर पॉट का मुझे मास पता नहीं फ्लावर पॉट का लेकिन इट इज केप्ट एट अ डिस्टेंस ऑफ 2 meters व्हाट विल आई डू आई जस्ट पुट द मास bring this 2 here 100 divided by 2 which gives me 50 newton meter that's the torque. You divide that with 10 or the weight you divide that by 10 you will get the weight of the object है ना newtons को weight में convert हो जाएगा congratulations people fantastic this gives me 50 newton as the weight divided by 10 gives me the mass which is 5 kgs congratulations awesomely well done people awesomely well done so the answer comes out to be 5 ज़्यादा हो गया 5 kg check करते हैं oh yes Congratulations, people. Congratulations, people. You have mastered the game of balancing. Thank you so much, Bill. Thank you so much. You all did absolutely fantastic. बहुत मजा आया. I really hope all of you enjoyed it. I would request all of you guys to go forward to this particular website, and this is a free website. It's absolutely free. I would request all of you guys to go ahead and provide some support to them. Come on, go ahead and do that. Okay, provide some support to them. Cool. Okay. तो people हम चलते हैं अभी हमारे सेशन में वापस आ जाते हैं. ठीक है, तो सेशन वापस आ गए. I believe all of you guys enjoyed this particular part. मजा आया सबको? Hit that like button if in case you all enjoyed. अब चलते हैं हमारे सबसे इंपॉर्टेंट पार्ट की तरफ. We are calling it as what? We are calling it as VIP. Come on, people. What is the full form of VIP? And yes, Dhruv Raj and everyone, congratulations. You won the game. You all won the game, people. Super proud. Abhijit ji, you can see it on the top URL. You can see on the screen. Yes. Thank you so much. Yes, बल्ले बल्ले मजा आ गया. कितने लाइक्स हो गए? चलो देखते हैं. 500 प्राइस स्टॉक कर दिया हमने. 4:38 PM, 4:45 PM. Abhi, there are still 250 likes left to cross 700. Come on, people, come on. ठीक है, चलो. Very important problems. Yes, now you know what is VIP, right? VIP is nothing but very important problems. I just have two questions to ask based on the principle of moments. That is, sum of anti-clockwise moments is equal to sum of clockwise moments. Come, go ahead. Question number 1 on your screen, people. आपके साथ आपको ग्राफ के साथ दिया हुआ है, डायग्राम के साथ दिया हुआ है. मचाओ. The diagram shows two forces, F1, F2, 5 Newton, 3 Newton, acting at points A and B of a rod pivoted at a point O, such that OA is equal to 2 meters and OB is equal to 4 meters. Calculate the total moment of the two forces about O. What do you guys think is the correct answer? No problem, smart learning. No problem, smart learning. People, every session of ours will always end with very important problems and amazing games like this. Hey Arya Kumar, good afternoon Manisha. क्या लगता है उसका आंसर आगे बच्चों? You like me, sir? Hari, thank you so much. Yes, Sungal. 2 meters towards right, 2 Newton meter towards the right. Gangadhar tells me 2 Newton meter towards the right. You guys tell me 12 meters. You have to find out the total moment of the two forces about O. That means you need to find out the resultant moment here. What do you guys think? Acha. Okay. Thank you so much, Dipun. 12 Newton meter. That's what you guys think? Acha, let's find it out. Okay. Let us try to find out what is the total anti-clockwise moment here. Okay. Let's try to find out what is the total anti-clockwise moment here. ACA. कितना होगा? Anti-clockwise moment is generated by this force here. है ना? This force. Why? Because this force will rotate the object towards anti-clockwise. Correct? You can see that, no? This is anti-clockwise. Correct? Yes. So 5 into 2. 10 Newton meter. Super. Let's try to find out what is clockwise moment here. Clockwise moment is going to generate by this F2, 3 into and downward, distance at 4. So 3 into 4. What is the formula I'm applying? Torque or moment is equal to force into distance. That's what I'm applying. The same formula. 12 Newton meter. Oh, look at that. So this way it is 10 Newton meter, but this way it is 12 Newton per meter. So what is the resultant moment? What is the total moment on the object? Clockwise moment is always taken as negative. So the total moment is minus 2 Newton meter, people. Minus 2 Newton meter, correct? So minus 12, a resultant moment plus 10 will give you the answer as minus 2 Newton meter. It's not necessary that you have to mention 2 Newton meter in clockwise direction. You can also mention it as minus 2 Newton meter because negative sign itself indicates clockwise moment. Okay? Congratulations, people. And minus 2 looks like the correct answer. Fantastic. Good job. D option. Chalo. Last question for all of you guys today. Last question. Give your best. I want everyone to give your best here. Here is the question, people. On a seesaw, two children of masses 30 kg and 50 kg are sitting on one side, not on both the sides. On one side, 30 kg person is sitting at 2 meters and 50 kg person is sitting at 2.5 meters, respectively, from its middle. Where should a man of mass 74 kg sit to balance it? What do you guys think, people? Come on. Arey Parthaji, namaste. है ना? What do you guys think is the correct answer? 2.5, 3.8, 1.2, 1.5, A, B, C or D? Come on, come on, come on, come on, people. Give your best, give your best. Give your best. What is Kalyani? Didn't get you. 3.8 you guys said. Acha. Dev 9 you get 3.8. Acha, ठीक है. Kunal also get 1.2. Acha. Divya gets 3.8. 3.8. A few of you guys. Sambhav is getting option A. Thank you so much, Raya. Means a lot. Option A, people. Yes, Kamlesh. Nandana, yes, I am. Yeah, people, get it? Option A, B, C. I see a sort of confusion. A majority of you guys are going for 3.8. That's something interesting. But a lot of you guys are also getting option A as the answer. एक काम करते हैं, check करके देखते हैं, ठीक है? Let's try it out by ourselves. Let's draw the diagram. It will help us. ठीक है? So here is a seesaw. This is the center of the seesaw about which the object will rotate. The 30 kg object, the person, is at 2 meters. है ना? 30 kg person is at 2 meters. So this is the 30 kg person. It's at 2 meters from the middle. And the 50 kg person is at 2.5 from the middle. 2.5 from the middle. We need to find out where should this 74 kg person sit from the center. This is what we need to find it out, so that the equilibrium is achieved, the balance is achieved. So to achieve the equilibrium, people, what is the formula? Sum of all the anti-clockwise moment should be equal to the sum of all the clockwise moments. ACM should be equal to CM to achieve equilibrium. They are asking about equilibrium. They are asking about balancing it. So we have to apply the formula of principle of moments. Okay. So what is it? What is the anti-clockwise moment here achieved? This is kgs. We need to convert this into newtons first. We need to convert this into forces, newtons, weight. So what would that be? Let's try to find out. Or we can also do one thing to keep it simple. Na? Let's not convert it at all. Convert नहीं कभी करेंगे weight में, तब भी आपको आंसर मास में आ जाएगा. वरना weight में आप convert करोगे, फिर end में आपको मास में convert करना पड़ेगा by dividing by 10. Both the formulas you can achieve. Both of the way you can go forward. I'm pretty sure you are aware of this now. So now, what is the anti-clockwise moment generated by 50 kg? 50 kg is at 2.5. So 50 into 2.5. Not converting it to newtons. Huh? Next, plus 30 into 2. That's also providing a anti-clockwise moment. So 30 into 2. Awesome. This is equal to, what are the clockwise moment? Clockwise moment is generated by the 74. 74 is clockwise moment. Na? So 74 is the mass, but I don't know the distance. So I'll take it as x. I know the distance, so I'll take it as x. Okay. Now calculate this. 50 into 2.5 is 125 plus 60 is equal to 74 into x. So x becomes equal to 185 upon 74, and when you equate it, you will get the answer as 2.5 meters. So it is option A. It is not option B. A lot of you guys gave me option B. No, it is not option B. Take it? Okay, people. Fantastic. Come on. I really want all of you guys to give a huge round of applause for each other, because that, my dear students, is the end of today's session. Come on, give a huge round of applause for each other. जल्दी से. कितने likes हो गए? 480 पहुंचा है बच्चों. 480 पहुंचा है. 500 नहीं हुआ अभी तक. पिछले सेशन में 500 हो गया था. 500 नहीं हुआ अभी तक. जल्दी. Okay, just kidding. Thank you so much for all your amazing support for this session. सबको मजा आया? Always enjoyed it? चलो ठीक है. I'll stay back right now for another 2 or 3 minutes just to talk to all of you. But I would like to mention the homework for today. Here is the homework for today for everyone, people. I want all of you guys to note this down. A very beautiful question. Try it out. Let me see who gives me the correct answer in the comment sections first. Okay. And I'll put the names of all those friends the same way how I did in today's session. In the comment section, people, I want all of you guys to mention 3 things. How much you love today's session. How much you love the game. I really want to know that. Number 2, because I'm pretty sure none of the other videos, none of the other channels have done that till now. Hai na? So do let me know, so that gives me more motivation to do this kind of stuff in these sessions. Okay. So number 1, do let me know how much you love this session. Number 2, mention the homework answer in the comments. And number 3, do let me know if in case you have any doubts related to this topic. Also, I would like to make you guys informed, and I've always done that, people, ki at the end of this chapter, there will be a separate session where I'll take all the doubts from the comment section, whatever is more relevant and whatever is more common. I'll deal with that in the last session of the chapter, where I take all your doubts and also play an amazing quiz with all of you guys on Menti. तो हर सेशन को अटेंड करते रहना, भूलना मत. ठीक है बच्चों? और उसके अलावा I also want you guys to remember about the link which is given at the end of this video, or also given in here, vdnt.in/ytvsat, about the VSAT examination, which is absolutely free and which you can write down in the comfort of your home to get an assured scholarship. Do not waste any time here, because VSAT is a very seasonal examination, does not happen throughout the year. तो बच्चों जाना है आपको, लिखना अभी क्या है, enroll right now. ठीक है? Okay. So I believe all of you guys took the screenshot of the homework and everything. And yes, we have covered equilibrium and torque, both the topics. And the next session that is going to happen tomorrow at 4 o'clock, we are going to cover numericals or torque and principle of moment. तो यानी कि torque and couple के numericals पूरे के पूरे सारे important numericals और principle of moments के सारे important numericals we're going to cover it today. So any student who haven't watched this session completely must watch this and the previous session also. ठीक है बच्चों? Yes, Shiv Pratap, almost all the days. Thank you so much, people. I hope all of you guys enjoyed it. Now I talk to you guys. What's up? Hey, 508, 700 तो नहीं हुआ आज. कोई बात नहीं. We are sticking to the previous record. That's okay. 500 likes. That's okay. Thank you so much, Nandana. Yes, thank you so much, Simran. Thank you so much, people. Best homework. Thank you so much, Priyanshu beta. Thank you so much, Simran, again. Hello, people. Sir, what about NDA? Beta, we don't handle NDA, but you can definitely go to the V Math channel, Sahaji. That's Vedantu's math channel. There they train for NDA. Hey, Manju, thank you so much. Thank you so much, Manju. है ना? थैंक यू सो मच पीपल. तो बच्चों जो सिमुलेशन मैंने दिखाया वो जो मैंने गेम दिखाया था दैट्स fact.colorado. आप यू जस्ट सर्च फॉर ऑन गूगल फॉर बैलेंसिंग सिमुलेशंस. यू गेट. अरे जय श्री कृष्ण सिद्धार्थ. थैंक यू सो मच. हे मानसी, थैंक यू सो मच बेटा. थैंक यू सो मच अंशु. थैंक यू सो मच बेटा. ओके विमान. थैंक यू सो मच विमान. थैंक यू सो मच ऋत्विक. Thank you so much, Monal. Yes, Siddharth. Yes, Prateek. Thank you so much. Balle, everyone. Great job. Thank you so much. Saji, no, I am not the right person for that. But definitely try. Thank you so much, Monal. Anshu. Yes. Thank you so much, Kamlesh. Yes, Shiva. Okay, well, thank you so much for all your amazing comments. Do let me chat में जो भी आप डाल रहे हो डालते रहना, लेकिन do not forget to put on the comments also because that is what is gonna stay and that is what I'll keep on looking at to get motivated. ठीक है? So with that, people, end the session today. Thank you so much for this amazing feedback for all the Umang sessions which we have taken. Do try to watch all the other teachers Umang sessions also because we have started full on for ICSE 10th, physics, chemistry, mathematics, biology and English. So do not miss out any of this particular subjects. Please take care of that. Bye people, take care. If in case you haven't subscribed yet, subscribe right now, like right now, share right now, and also in the comment section, do not miss out to put down those 3 things which I asked for all of you guys. People, until we meet the next time, this is Abhishek signing off. Keep enjoying.